Hi students, today we're going to do chapter 6, and for chapter 6 I don't really follow the book, so they don't go section by section. Stable electron configuration. A stable electron configuration is elements with a full outer energy level. They do not want to react with other elements. Most elements want 8 electrons in their outer energy level. There are a few exceptions, like helium is okay with just 2 electrons in the outer energy level. A little bit more about stable electron configuration. There are 3 methods to obtain a full outer energy level. Atoms share valence electrons, atoms gain valence electrons, or atoms lose valence electrons. Compounds. Compounds we talked about back in chapter 2, but a little bit more about them in this chapter. Compounds are any combination of 2 or more elements. Elements combine with other elements to fill outer energy levels. The exception would be noble gases because they are already stable with their 8 electrons in their outer shell, or helium with its 2. Formulas. Formulas are the shorthand method of writing chemical names. For example, water. You might know water is H2O. The H and the O are the symbol of the elements that are involved. The 2 in the absence of a number is the quantity of each element needed. Those numbers are called subscripts. And it is important to know that that is a vocab word. For oxygen, there's no number written, and that means that there's 1 oxygen. Never ever write 1 as a subscript. Ratios. Ratios are formulas that tell us the ratio of elements needed. The H2O tells us that there's a ratio of 2 hydrogen to 1 oxygen in water. We could also write it as 2 to 1. C6H12O6 has a ratio of 6 to 12 to 6. Or you could simplify that, because 6, 12, and 6 are all divisible by 6. You could simplify that to 1 to 2 to 1. Electron dot diagrams. Electron dot diagrams is a model where each dot represents a valence electron. It allows us to see how many electrons an atom must gain or lose to achieve a full outer shell. There are 2 parts. The element symbol represents the nucleus and all inner energy levels, and 1 to 8 dots represents the number of valence electrons. So here is some pictures of dot diagrams. You might want to draw at least 1 row in your notebook so you know what it is. So if you draw the second row with lithium through neon, that would be good. And it does represent their valence electrons. So lithium has 1 valence electron, so because it's in group 1, so there's 1 dot, and so forth. Notice that you do not double up dots on sides until you get to group 5. So once you get to group 5, which has 5 valence electrons, they do start doubling up on sides. So we're going to do 2 practice ones. We're going to do arsenic and bromine. So first you got to find arsenic on the periodic table. So if you look, arsenic is right there on the periodic table, and it has 5 valence electrons. So we need to start with drawing arsenic. You first draw the symbol, and then you want to draw 5 valence electrons. So start going singly first. So I've got 4, and then you want to double up one side. That would be arsenic. Now let's do bromine. Bromine is right here. It has 7 valence electrons because it's in group 7. So you start with the symbol, which was Br, and then we want to draw 7 dots. So you go singly first, and then you want to draw, then you can double up. So bromine needs 3 more. Now when you do double up, you want to make sure that they're both next to each other. You wouldn't want to have a dot diagram look like this. That is bad because these dots are not next. The second dot that you drew is not next to the symbol. So this is bad. I don't want to see that. That is it for today's notes.